On December 25, 2021, the Ariane 5 rocket launched James Webb into space, a huge space telescope that has cost approximately $10 billion so far. But why is such an expensive telescope necessary? It is so that mankind can see into the deeper past and know how the first stars and galaxies were formed. Hi folks, it's not hard to imagine that the first images caused quite a sensation when the observations were published. James Webb was reported in headlines for turning cosmology upside down. But is it really true? Welcome to our channel, everyone. So, from now on, let's look at this question together. Let's get started, but first, already leave your like, subscribe to the channel so you don't miss out on amazing videos. Why infrared? The main mission of the James Webb is to see beyond the Hubble Space Telescope. James Webb can observe not only visible light, but also in the near and mid-infrared. Infrared telescopes allow us to record the redshifts of very distant objects with very old formation dates. As everyone knows, the light we see from a star was emitted by that star many years ago. Even the Sun, the closest star to Earth, takes 8 minutes and 20 seconds for its light to reach us. What about the more distant objects? The celestial body itself may no longer exist, however we can still see the light that is left behind. And that is a good thing, because the light emitted billions of years ago can tell us a lot about the evolution of the universe. But scientists have to take into consideration many factors, such as redshift. Redshift is a physical phenomenon in which the greater the distance light travels from its source to the observer, the longer the wavelength of light. There are several possible reasons why this happens, but from a cosmology point of view, the expansion of the universe plays an important role. The redshift measurement may provide experimental data for further discussion. The James Webb is equipped with several devices for this purpose, including a near-infrared camera. In addition, the telescope itself is large enough to define how long it took for light to reach it and how far it traveled. Both distance and travel time are calculated according to the specific model that describes the birth and evolution processes of the universe. And this is where the most interesting things happen. What happened after the Big Bang? Let's start with the cosmic microwave background radiation, which was predicted by George Gamow, Robert Herman, and Ralph Haffer in 1948. They took the famous Big Bang theory as their starting point. 17 years after this prediction, Robert Woodrow Wilson, who later won the Nobel Prize, and Arno Penzias accidentally discovered the cosmic microwave background radiation, confirming the validity of the theory. According to current thinking, the cosmic microwave background radiation happened approximately 380,000 years after the Big Bang. At that time, in the expanding universe, the plasma temperature dropped to 3000 Kelvin and electrons and protons began to come together to form atoms, allowing photons to travel. In fact, this became the cosmic microwave background radiation. After this proof, various cosmological models were developed, leading to the discovery of the phenomenon of the accelerated expansion of the universe in 1998. In distant galaxies, Type 1a supernovae, also known as standard candle, were found to be fainter than expected. This is due to the fact that the universe is expanding at an accelerated rate. The cold dark matter model that prevailed at the time has been replaced by an extended model called lambda-CDM, which can better explain the contradictions that have arisen. Even today, this model is considered dominant. What did James Webb manage to discover? In 1985, Riccardo Giacconi, director of the Space Telescope Science Institute, suggested to his colleague Garfield that they consider planning a next-generation space telescope. That is the Space Telescope, now known as the James Webb. This was 5 years after the launch of the famous Hubble telescope. Even then, it was considered necessary to build an infrared telescope to study the early universe. The fact that the terrain surveyed by the Hubble telescope was an area of relatively low stellar density also helped support this argument. This area, known as the Hubble Deep Field, is apparently an uninteresting corner of the universe, but scientists have found clues about the universe in the past and have been able to explore up to 12 billion years of the 13.8 billion years of cosmic history. The oldest object captured by Hubble is the galaxy GNZ11, which has a redshift of 11, discovered in 2015. The redshift of 11 corresponds to a cosmic age of approximately 380 million years, which scientists say is when galaxies began to form. It was hoped that James Webb could see farther, and he succeeded in his first attempt on July 11, 2022. An image known as James Webb's first dove field was released in a presentation to U.S. President Joe Biden. The galaxy cluster in the picture is SMS 0723, which has a strong gravitational lensing effect, and many galaxies in common have been discovered deep within this cluster. Among them is Glass Z13, with a redshift of 13.1, discovered by the team of experts 330 million years after the Big Bang. It is a 13.45 billion-year-old galaxy. Is there any object in the universe older than this? Yes, there is. In April 2022, a research team from the University of Tokyo used the Subaru telescope to observe the HD1 galaxy at a redshift of 13.27. But it doesn't end there. One of the objects considered to be one of the oldest is the galaxy Source 93316, captured by James Webb's infrared camera. This galaxy has a redshift of 16.7. That means it is 235 million years after the Big Bang. Why James Webb's discovery rocks cosmology. Before we go any further, the three galaxies mentioned above and the others discovered by James Webb are the leading candidates for most distant objects. At the moment, some of them have a disk-like structure. This is quite unusual for such an early galaxy. Another galaxy about the same size as the Milky Way, with a redshift of 10, has also been discovered. By the standards of the lambda CDM model, this is also unusual because its emergence is so fast. In fact, James Webb's discovery raises doubt about this model. Suppose that the first stars were formed 100 million years after the Big Bang of those stars. Then they interacted and broke away from each other to form the protogalaxy. The structure of the universe we know today was created approximately 1 billion years later. Yet, James Webb shows that the first galaxies with sufficient mass appeared only 200 million years later. Isn't that strange? To understand how much cosmology has been shaken up, it must be clear that all these galaxies are only candidates at the moment, and their ages are uncertain. Since the publication of James Webb's observations, a kind of race of discovery has begun, and the results are published without peer review. Although sensational, they are not always reliable. For example, a galaxy with a redshift of 20.7 was identified with a redshift of 0.7 after remeasurement. Another reason for incorrect dating was that the dust caused irregularities in the luminosity of galaxies, making nearby objects appear distant. There is something else we are interested in as well. What happens if the ages of the oldest object candidates are determined? What does this mean for modern cosmology? At the very least, the lambda CDM model will have to be revised. There have been several such changes in cosmology in the past, so there is no need to assume that the universe has been turned upside down. It was only our picture of the universe that was destroyed. In the future, scientists will have to look for reasons for the accelerated star formation in the early universe. Perhaps the increased temperature and pressure during this period encouraged the fusion of matter and the formation of stars. If the magnetic field had developed earlier than is currently thought, this process could have been even more accelerated. Supporters of modified Newtonian Mond dynamics have seen this source of ideas and have suddenly regained an enthusiasm. They consider this new data to be evidence for absence of dark matter and confirmation of Mond's theory. Cosmologists are in anticipation. The James Webb Telescope may have confirmed a large redshifted object. This means that they will have to revise their opinions about the early state of the universe and the lambda CDM model. And that is exactly what the James Webb Telescope was set out to do. Incredible! We are all looking forward to more information. If you are also excited, please leave your likes and comments here on our channel. Well folks, we are coming to the end of today's video. Thank you all for watching, and please don't forget to subscribe to our channel if you are not subscribed yet. We have 2 more great videos to point you to. They are playing on your screen right now. See you in the next video. Bye.